As we start looking at our concepts in statistics, our essential question at this point is, how is data centered? All right, and there's a number of ways that we can think about the center of data. We're going to look at 3 specifically today. We're also going to look at the kinds of data that we could be dealing with. Some of this will be significant throughout the entirety of our study. These 4 right here, nominal, ordinal, interval, and ratio, these are more going to be particularly significant if you choose to do a statistics topic for your IA. We'll talk about those. So it's kind of an interesting look there at the data. And then some other things that ought to look pretty familiar to us. Some other vocabulary there. But whenever I post this vocabulary, this is stuff that I expect you to know really, really well by the time we're done. To where if I just mention it, you have certain things popping into your head. Okay? Now, there's some other kind of vocabulary that is used in statistics, and it says you should already be familiar with. You might, how familiar you are might vary, but there are some terms that you have probably at least heard of before. These first 4 kind of go in pairs: population, census, sample, and survey. The population is the entire collection that you are getting data about. Okay? And it says here that it's about which we want to draw conclusions. All right? The reason why we do statistics is so that we can draw some kind of a conclusion about the population. All right? If we're studying, the student body here at school, the student body would be our population. Okay? If we wanted to use the school as to represent other high school students or something like that, then all the high school students would be our population. The ones in this school would simply be a sample. Okay? A sample is a subset of the population. Now, there are a couple of things, and this will be important as you guys do IAs again, is when you use a sample, it should be somewhat randomly selected, and it should avoid bias. Okay? This is a really, really important thing anytime you're using statistics, is that if you're going to use a sample, you have to pick it randomly. And there are different kinds of randomness. We're not going to get into that. But in other words, it should be representative of the population. All right? For example, games are played with statistics in politics all the time. People will use statistics to try to say what they want to say all the time. For example, if I were, let's say I were a Democrat trying to push this certain agenda, I might do a survey, but I might only survey people living in like San Francisco or New York City, which tend to be more liberal areas. Okay? Why? Because they're going to give me the answers that I want. Okay? If I'm a Republican and I want to push a certain agenda, where might I survey people? I might go to like some Midwestern town or somewhere, in the South, like in the Bible Belt or something, and or in Texas, really conservative areas. That's why it's important when you look at statistics that you look at who did the survey, who ran the survey, what was their selection method for their sample, Also, making sure that the sample represents who they're trying to describe. It represents the population. Okay? If I am trying to draw some conclusions about the student body at North Broward, I can't just survey high schoolers. I would have to go down to the lower school and survey some kindergartners and survey some third graders. And okay, if I want it to truly be representative, and that's why I said somewhat random, you need to make sure it represents your whole population. Okay? But it can't be biased, all right? If I only surveyed the high schoolers, then my results would only be relevant to the high school population, all right? And sometimes it's really easy to try to misapply results from data to a population that it doesn't represent, okay? Now, I talked about doing a survey. A survey is different than a census. Here in the United States, every 10 years, the government sends out a census, okay? It usually takes a couple of years to get it all compiled and get the data. Like I think the 2010 census, a lot of the data was finally released in about 2012. But what that is they actually send a survey out to every household in America, and in fact, if they don't get it back from you, they hire people to go door to door, knocking on your door and almost force you to take this census. I mean, you can refuse still, but they'll send someone to your door because they want data from the whole population. So what do they do in the 9 years between censuses? They do surveys based on samples. Okay? They'll take a sample of the country and do a survey. And by doing those every 10-year censuses, and using the surveys, they can tell trends, and then those trends and those things that they're predicting are either confirmed or rejected the next time they do the census. Okay, so it's a pretty good system. There are different kinds of variables. Categorical. These are things that describe qualities. Like if we were counting how many people had brown hair. Okay, that's a categorical variable. Or how many are IB diploma candidates. That's a categorical variable. We also have numerical variables. These are describing characteristics that have a numerical value. Okay? You know, what is your GPA? What is your height? Okay? Things like that. All right, so those are different kinds of variables. You can look at parameter and statistic. Okay? A parameter measures some aspect of the population. A statistic is calculated from data that we got, and it's used to estimate something about the population. Okay, so here it's kind of, again, you've got the sample versus population idea. Okay, we use a statistic to estimate. It's important to recognize that we are estimating. Nothing here is guaranteed. When we're using samples. But we can get a pretty confident result a lot of the time. Distributions, okay, the pattern of variation. We can have symmetrical, looks kind of like a bell curve. All right, we have positively skewed. Now notice, most of the data is to the left, but you've got a bunch of these higher values down here that if we were to find the mean, it's going to push that mean positive or higher than where most of the data is. Negatively skewed, we've got a number of these really low values that are going to pull the mean lower than where the majority of the data is. Okay? And then we have outliers. We'll talk about outliers a lot more. Basically, they're just really abnormal results. They're ones that lie a long way away from where the majority of the data is. Okay? So, but we'll look at that more for you guys Thursday. So, but let's take a look at two types of variables, or two types of data that we need to make sure we keep straight. Continuous and discrete. Okay? I spelled discrete wrong. That's terrible. Discrete. And it's right below it. There we go. Discrete numerical variables take exact values and are often the result of counting. In other words, there are no values between the values. Okay? In other words, like we mentioned before, for example, if we're counting the number of people who have brown hair, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, I guess. So you're kind of between. But that would be a discrete variable. We don't have 9.5, or it's not on the sliding scale. They're exact values. A continuous variable is something that often is the result of measuring. Okay, if we're measuring people's height, we could have 5'6.5" or 5'6 1/8. Or we have this continuous scale. And actually, the difference here is, one of the differences is that when we're dealing with discrete variables, often we'll get a lot of values that are the same. When we're dealing with continuous variables, it's almost impossible to get two of exactly the same value. So often what we'll do is we'll put these into categories. Like if we're measuring people's heights, which is a continuous variable, in order to analyze it a little more, we might put them into categories, like the people from 5 foot to 5'2", and then the people who are taller than 5'2", which up to 5'4". We have these ranges, or we call them classes, that we'll put them in. Now, when we are representing this data in a bar graph or a histogram, we do it a little bit different depending on whether it's discrete or continuous. If you'll take notice here, if we have discrete variables, then we're going to use what's called a column graph, and you'll notice each of the bars are separated. Okay? And the frequency that they occur in is on our y-axis. All right, but that's for discrete. Continuous data will use a frequency histogram. Okay? And what we do is we divide it up into intervals or classes, like we said, of equal width. Okay? So like 2-inch height ranges or something like that. But notice there are no gaps between these when we draw it. Okay? So guys, when you see a graph like this, at a glance, you can tell, if it's constructed properly, you can tell whether the data is discrete or continuous. Just by looking, are there gaps between the bars, or are they all shoved together? Okay? Now, this next part is not in your books. All right, so this is something that your independent practice and those kinds of things are not going to necessarily ask you about, but these are going to be some things that you're going to need to pay attention to, again, if you choose a statistics topic for your IA. Okay? Certain statistical tests require certain types of measurement. Okay? And we're going to look at these starting with the most general type, or most general scale, and moving to the most specific, or higher level, we could say. First of all, the nominal scale. Here we're naming or classifying objects that we can count. All right, again, counting people with brown hair, counting red cars. All right, anything that we can count, we're just putting them into a classification. How many people are Ivy diploma candidates? How many people are taking AP human geography or whatever? We're putting them into classifications. That's the nominal scale. Secondly, we have the ordinal scale. Yesterday, when I asked you guys to rank the topics from pre-cal honors in order from what was hardest to what was easiest, you were using an ordinal scale. Okay? You were ranking them. Now, some of you didn't quite understand what I was asking, so you had like 3 1s and a few 4s or something like that. So, but the ones who did it correctly, you were putting them in an order. However, the difference is we can't tell the difference between them. For example, 2 of the topics that we covered last year might have been really challenging for you. And one was just a little bit harder than the other for you. But the third one might have been a whole lot easier than that second one. See how that is? There's just a little bit of a gap, a difference between the first 2, but then there's a huge difference before the next one. It's kind of like the last race of the Kentucky Derby. All right, American Pharoah won by a lot. You guys see that? Was it the Preakness was the last one? He won the Triple Crown. It's the first time that any horse had done that since like 1970s or something. No. I'm not a horse racing fan, but when something happens for the first time in like 40 years, it's worth noting. Anyways, he won by a lot, and then second, third, fourth, a bunch of other horses were all clustered. The fact that he won by a lot, it didn't give him like bonus points for next time or something. It's just he got first place, the next horse got second, the next horse, even if it was only, a tenth of a second behind the second place one, he still got third. It's still first, second, third. There's an order, but we don't know what the difference is between them. Or there's at least not a consistent distance between them. Okay? And these rankings, they're actually tests that people will use. One's called the Spearman rank. But it's a test that people use to judge consistency in judging. For example, I'm sure the Olympics will use it, but when they have different judges judging like figure skating or whatever, are there rankings of, they're not necessarily concerned about the scores, because someone might say it's a 5.9, and others say a 5.7, but when this guy goes up to a 6, does this guy go up as well? Are they at least ranking people in the same order? The Spearman rank test will actually tell if there's a significant difference in the way 2 judges are ranking. Okay? They'll do this for art competitions or whatever, things that are a little more subjective. And they'll compare the results and they'll determine, okay, we should probably bring in a third judge, to kind of get another opinion on this. Okay? But that's the ordinal scale, putting things in an order. Then we have the interval scale. And the interval scale and the ratio scale are very, very similar. Here we have values of variables that are ordered, but they're ordered in a way that there is a consistent distance, an interval, between the different values. Okay? The difference between interval and ratio, though, is that ratio will have an absolute 0. Okay? So, for example, temperature is an interval scale measurement. Okay? The difference between 89 degrees and 90 degrees is the same as the difference between 2 degrees and 3 degrees. there is a consistent interval of a difference in temperature. However, even though there's a theoretical Kelvin zero that's absolute zero, even that is arbitrary. There's an arbitrary zero, okay? A zero on a test, technically test scores would be interval scales. If you got a zero on a test, it doesn't mean that you know absolutely nothing. It just means you happen to miss all the questions on that test. If you have a GPA of zero, okay, it just means you got an F in all of your classes. Now, you could have gotten an F with 49s or an F with zeros, but you still got an F and your GPA says zero. So you have an interval scale, okay, but there's an arbitrary zero there. The ratio has an absolute zero. This would be things like weight or age, okay? You know, a person's age, there was a definite time when they were born, that's zero, okay? Their weight, you can't have negative pounds, right? So there, again, is an absolute zero. Now, the nice thing is, most of the tests all the tests that we're going to do, the difference between interval and zero isn't going to be relevant, okay? But there are things out there that you could only use ratio scale data for. Now, one nice thing is this. If you have data, let's say from an interval scale, you can generalize it down to nominal or ordinal. Okay, for example, if I have temperatures, obviously I can then order them from coldest to hottest, right? Or if I wanted to make general categories, cold, mild, and hot, I could fit those into a nominal scale. Okay, so you can take data from a higher level and fit it into a lower level. What you cannot do, though, is take things from a lower level scale and try to be more specific. Okay? You know, so I couldn't put, you know, the rankings of people, you know, in a race and try to make that some kind of an interval scale. It just doesn't work. All right, so those are different scales of measurement. And again, those are worth taking note of and understanding, especially as you head into your IA here in the near future. Let's talk about frequency and relative frequency, though. Frequency, this is a term you ought to be familiar with already. Frequency is the number of times a data value occurs. Okay? With discrete variables, that happens all the time. With continuous variables, we usually need to make classes. Okay? We'll make categories. Relative frequency often is more useful than frequency. Okay? For example, let's say that at my old school, when I was teaching my pre-calculus class, I never had more than one F on any test. That sounds pretty impressive, doesn't it? Well, that's a frequency. Relative frequency, though, if you knew that I only had like 7 students in the class, okay, that's a 14% mark. All right, so that sounds a little different than, you know, I never had more than 14% of my students. Sounds a little bit different than I never had more than one student fail the test, okay? Because in a class of 28, I could get the same percentage if I had 4 people fail, right? So that's what relative frequency kind of gives us. It's a percent out of the total data. Here's an example here. We have these scores 1 through 5, and they occurred this many times for a total of 30 different occurrences. However, 8 out of 30, since 1 occurred 8 times, 1 occurred 26.7% of the time. That tells us a little bit more than just saying, oh, it happened 8 times. Okay, because that could be 8 out of 30 or 8 out of 3,000. And that's really, really different. Okay? But that's the idea with the relative frequency. Here we would take 9 out of 30 and we get 30%. So 30% of the results were 2s. Okay? And so on. Does that all make sense? All right. Now, what I want to do at this point, before we go on to do anything else, is just give you some practice working with some of these ideas. And we're going to do that with a couple of problems. You can skip number 2, but we're going to do number 1. This is in the book on page 504 if you want to bring up the PDF of the book and look at it closer. What I want you to do is get with somebody and find a spot at one of the boards. I've got a bunch of markers over here you guys can use. But I want you to go ahead and work on these, and we'll do number 1 and then skip down to number 4. Okay, go ahead. Oh, here we go. That'll work. We'll do 1 and 4. Okay? So let's go ahead and start with that.
Who has worse hand? Mine's worse, so I should.
Is that A?